At 4:12 p.m., the primary region went dark. Not gradually, not partially, dark. Our monitoring screens lit up red across us East 1. API error rate hit 100%. Health checks from synthetic probes failed instantly. Pager duty triggered a major incident and auto-escalated to the entire on-call chain. In Slack, someone typed, "Failover should kick in any second." We had spent months building a multi-region architecture: active-passive, automated DNS failover, cross-region database replication, runbooks documented. This was the moment it was supposed to prove itself. Instead, 5 minutes later, global traffic was still failing. Environment context. We were running on AWS with primary infrastructure in US East 1 and a secondary region in US West 2. Both regions had EKS clusters. The primary cluster handled all live traffic. The secondary cluster ran in warm standby mode. Services were deployed but scaled down to minimal replicas. Traffic was routed through Route 53 with health checks. Traffic was routed on the primary load balancer. If health checks failed, DNS would shift to the secondary region. Our primary database was PostgreSQL on RDS in US East 1 with cross-region read replica in US West 2. In a failover event, the replica could be promoted to primary. CI and CD were GitHub Actions and Argo CD. Deployments went to both regions simultaneously to keep versions aligned. Monitoring was centralized through Datadog. Monitoring used Datadog and Prometheus with region-level dashboards. We regularly tested minor failovers in staging, but never a full production region outage. Initial symptoms: the outage was triggered by AWS networking. The networking issue affected multiple availability zones. Instances were reachable from within the region, but external load balancer traffic was failing. From the user perspective, the site was unreachable, not slow, not degraded, completely unavailable. Internally, metrics from US East 1 went flat. No incoming requests, no CPU load, just silence. The expectation was that Route 53 would detect the failing health check and shift traffic to US West 2, but traffic never arrived there. Looking at the secondary region dashboards, we saw minimal CPU usage, almost no requests, error rate near zero because nothing was hitting it. That was the first sign something was wrong. Investigation and escalation. First hypothesis was DNS propagation delay. Route 53 health checks had a 30-second interval with 3 failed checks required before failover. So roughly 90 seconds worst case. We waited. 2 minutes passed. 3. I checked Route 53 health check status. It showed the primary endpoint as unhealthy. Failover policy should have routed traffic to secondary. Then I ran a manual DNS query from my laptop. It still resolved to the primary region load balancer. That suggested either TTL caching or misconfiguration. The DNS record had a TTL of 300 seconds. 5 minutes. We had accepted that as reasonable. Under outage conditions, 5 minutes felt like an eternity. Meanwhile, customer impact was severe. Support channels were overwhelmed. Leadership was on the incident call. We decided to manually adjust DNS, but direct curls against secondary got 503 errors. So even if DNS shifted, the secondary region might not handle full traffic. That led to the next hypothesis. Warm standby configuration might not be production ready. I checked HPA settings. Most services were scaled to 1 replica. Auto-scaling required traffic to scale. However, the database in US West 2 was still a read replica. It had not been promoted. Our runbook required a manual promotion step before secondary could accept writes. In the chaos of the moment, no one had executed that step yet. We had assumed failover was mostly automatic. It was not. Root cause. The failure was not the regional outage. It was our incomplete automation. Combined with overly high DNS TTL, Route 53 correctly marked the primary region unhealthy. But because of the 300-second TTL, many clients cached the old record. Simultaneously, the secondary region was not fully prepared. The database replica had not been promoted. Write requests would have failed. Auto-scaling never scaled. Our multi-region architecture existed on paper, but in practice it required manual steps, mitigation, and recovery. We immediately lowered the DNS TTL to 30 seconds. Next, we promoted the RDS read replica in US West 2 to primary. That took about 4 minutes. We manually scaled critical deployments. Then we forced a DNS failover. Within several minutes, new client sessions began resolving to US West 2. Traffic gradually increased. CPU in the secondary cluster climbed but remained within safe limits. Error rates began dropping. Total impact lasted approximately 25 minutes. Post-mortem reflection. What actually failed was our assumption that multi-region equals automatic resilience. We had built redundancy, but not fully automated the transition. Engineering lessons. First, multi-region is not just duplicate infrastructure. It requires automated promotion of stateful services and rehearsed failover drills. Second, DNS TTL is a reliability lever. Shorter TTL increases flexibility. Third, warm standby must be capable of handling immediate load. Fourth, disaster recovery plans should be exercised regularly. Fifth, resilience is a chain of dependent mechanisms. If any link requires human intervention, it is a risk. That day taught us that having a backup plan is not enough. The backup plan must be ready before you need it.